look at the examples of condensing with logarithmic properties. So this first problem we look at, we start by looking at the problem and we say, do we have any numbers, or it could be variables, in front of the logarithms? And we don't, so we don't have to worry about that. So the second thing that we do is we look and we see this problem has subtraction in it. And because it has subtraction in it, we can combine this, we can turn this logarithm into, we can turn this problem into one logarithm if we take 32 and we divide by 2. We're applying that quotient property of logarithms. So we're looking, if you look up at your chart there, here's an example of something that's subtracted. That's on the right side. And then we're going to turn it back into the left side. Well, in this particular problem, 32 divided by 2 can be calculated. So this is going to become log base 4 of 16. And then the question is, can we figure out what log base 4 of 16 is? And we can. We know two numbers of this. And you know that I oftentimes like to write equals p. So this becomes 4 to what power equals 16. And what we know is that 4 to the second power. So really, when we condense this, it turns into 2. So there's our first example, and it probably takes a couple of examples to figure out what's going on. But when we look at these problems, the first thing that we look for is, do we have a number in front of a logarithm? And on this particular problem, we've got a number in front here, and we have a number in front here. And when we have a number in front of the logarithm, we're going to use the power property, which says that we can take this 6 and we can write it as an exponent. We can take this 5 and we can write it as an exponent. And this is going to become log base 2 of x to the 6th plus log base 2 of y to the 5th. But once again, our ultimate goal is to write these problems with only one logarithm. So we look in here and we see that these two are added together, which means we're going to use the product property. And consequently, what's going to happen is we're going to take x to the 6th, and we're going to multiply it by y to the 5th. And now what we've done is we've turned a logarithmic problem with 2 terms into a logarithm with 1 term. Problem number 3. Again, every time we start these problems, look, do we have a number in front of the logarithm? We only have one of them this time. That is 4. And when we have a number in front, we're using the power property of logarithms, and we're going the other direction, which means that we're going to take that 4 and we're going to write it as an exponent. So we have log base a of 7 plus log base a of 3 to the 4th. And then you have a little leeway here. We can figure out what 3 to the 4th is right now, or we can do it in a couple minutes. It doesn't make any difference. I think we can figure it out right now. And maybe you didn't even write that last step. Maybe you went directly to the fact that 3 to the 4th is 81. Well, once we get that simplified, we dealt with the coefficient on the logarithm, turning it into an exponent. We want to turn this problem into one logarithm. And what we see in terms of operations is we see an addition. So very, very similar to problem number 2 with the addition. All that it says that we're going to do is we're going to take 7 and we're going to multiply it by 81. And then we finish by multiplying 7 times 81. We get log base a of 567. I just multiplied 7 times 81. And you can use your calculator to do that. Number 4. Yet again, do we have any numbers in front of our logarithm? And we've got one. And sometimes the issue is this fraction here. Also note that this is a natural logarithm, which is the ln, but the properties apply to log, the common logarithm. They also apply to the natural logarithm. So we can rewrite this as natural log of 8 to the 2/3 minus natural log of 3 to the 4th minus 8. And maybe we figure out what 3 to the 4th is, which is 81 minus 8. And maybe you did the whole part there. Maybe you did 81 minus 8 all in one step. But I want to come off to the side here for a second and remind you of what 8 to the 2/3 equals. Fraction exponents means we're going to have a radical, 8. The denominator of the fraction goes in the check mark part of the radical. And then you can put the 2 underneath the radical, or you can write it outside. It doesn't make any difference. But that's what 8 to the 2/3 power equals. Realistically, some of you are just going to type it in your calculator, 8 to the 2/3. But I want to remind you what it means. The cubed root of 8 is 2. And then we square that. 2 squared is 4. So really what natural log of 8 to the 2/3 equals is the natural log of 4. Over in the second term, we figured out that 3 to the 4th is 81. 81 minus 8 is 73. So this is going to be the natural log of 73. And this time, we're going to use the quotient property of logarithms because there's a minus in the problem. And our goal is to write the problem with only one logarithm. That's what condensing means. So this is going to be the natural log of 4 divided by 73. We cannot do anything else to that problem. If we could simplify the fraction, we would, but we can't. Turning our paper over. We've got a lot going on in here. And one of the things that I notice is that we have some like terms here. But I think that I'm going to go ahead and just go left to right on this problem. And it's not the only way to do this, but let's just condense these two. Oops, these two first of all. No numbers in front of the logarithms, and it's added. So this is going to become log base 4 of 5 times x. And technically I need the parentheses there. The next term in the problem is plus log base 4 of 4. There's another plus in this problem, and let's just condense those two, and because there's a plus, we're going to multiply these. So it's going to be log base 4 of 5x times 4. It's fine that you write it as 20x. In fact, I think I will just one more step here. Log base 4 of 20x. And so far, we've dealt with this term, we've dealt with this term, we've dealt with this term. So now, we're on to the next, which is log base 4 of x. And we're still adding these two terms together. And when we add them using the product property of logarithms, means we multiply. So now it's going to be log base 4 of 20x times x. When we multiply 20x times x, we get log base 4 of 20x squared. We dealt with this term. So our last term, minus log base 4 of 2. This time we have minus. So we're going to use the quotient property. And when we do, this becomes log base 4 of 20x squared divided by 2. And then the question becomes, can we simplify that? And we can. 20 divided by 2 is 10 x squared. Number 6. Do we have any numbers in front of the logarithm? Yep. There we do. I'll take this 2, put it up here. Log base 4 of 6 squared minus log base 4 of 9. Maybe you didn't write down 6 squared. Maybe you wrote down what 6 squared equals, and I'm fine with that. Log base 4 of 36 minus log base 4 of 9. But our goal when we condense logarithms is only to have the word logarithm written only once. We have minus in here. That is the quotient property. Log base 4 of 36 divided by 9. 36 divided by 9 is 4. And at this point, the question is, can we figure out any more here? And we can. Log base 4 of 4 equals p. In other words, 4 to what power equals 4. And 4 to the first equals 4. So we were able to simplify this logarithm all the way back to a number. Number 7. Once again, I will probably do this the long way. As we look at this, I'm going to condense the first two. We get log base a of x times 9, which I'm going to write as 9x. Well, the next term, which also happens to be added, is log base a of x squared plus 1. And just like we saw on the first two parts of this problem, addition means that we're going to multiply. So this can condense into log base a of 9x times x squared plus 1. But we still have minus log base a of 5. Well, subtraction. Subtraction means that if we want to condense, we're going to divide. So this is going to be log base a of 9x times x squared plus 1, all divided by 5. And you do want to put these parentheses in to show that that's the entire value that's applying to that logarithm. You do not need to multiply 9x times x squared and 9x times 1. You can if you want to, but you don't have to. You don't have to distribute that out. Last two. I referenced on the front of the paper, and before I even get started with this, let's rewrite square root of x without the square root symbol. Remember that the number in the check mark, it doesn't have to be written. That's a 2 when we're dealing with the square root. Consequently, this simplifies to be the 2 goes in the denominator of the fraction, and there's no exponent. We could put a 1 in there. But the square root of x is the same thing as x to the 1/2. This is log of x to the 1/2. And over here, you still have the log x to the 6th. Minus in this particular problem. So we're going to be using the quotient property. And what that says is we can turn this into one logarithm when we divide x to the 1/2 divided by x to the 6th. But remember, we've seen it on a couple of problems, example 1 and example 6 that stand out in my mind. Can we simplify any more? And when we divide, remember, division means that we subtract the exponents. And I don't have my calculator open here today, but 1/2 minus 6 is 5.5. And then we get x to the negative 11/2. I think that's right. Yes, because 1/2 minus 6 is going to give us negative 11/2. So x to the 1/2 divided by x to the 6th turns out to be x to the negative 11/2. I kind of lost my negative in there, so I'll put it in a different color. But the directions say that we want to write this problem express powers as factors. So even though we've simplified this, when we finish, what we want to do is we want to take this exponent and we want to write it out in front of our logarithm. And we'll end up with negative 11/2 times log of x. Again, what we need to watch out for is we need to watch out for the cubed root of x squared. So let's take a moment and look at that. The cubed root of x squared we can rewrite. Because remember, what's in the checkmark part of the radical goes in the bottom of the fraction. Then we've got the x squared, so the cubed root of x squared is the same thing as x to the 2/3. This is going to be log of x to the 2/3 plus log of x to the 5th. We're finishing with addition. Addition tells us to multiply. When we condense this, so it's going to be x to the 2/3 times x to the 5th. And what do we do to exponents when we multiply? Well, we add. So we need to add 2/3 plus 5. And again, type that in your calculator if you need to. I know that my calculator is not working right now. The 2/3 plus 5 is 5 and... can't even write it. 5 2/3.
Isn't it 10/3?
And it's actually 17/3. Check me, please.
2/3 plus 5.
2/3 plus 5.
Oh, I did 2/3 times.
2/3 plus 5, 17/3. So now, again, we're trying to write this with one logarithm. So we've got x to the 17/3. And once we've done that, again, we want to write all powers as factors. So to finish, we're going to take this value. I'm going to write it out here in front. We end up with 17/3 times log of x.